Hello and welcome to this video. In this video, we will learn about, we will solve 15 problems more on quadratic equations and theory of equations. Till now, we have solved 45 problems. So we will try to solve problem number 46 to 60. Like always, I will say that when I'm reading the problem, you should pause the video, and only if you cannot solve the problem, only then look at the solution. So question 46 says that if x plus y is equal to 1 and x to the power 4 plus y to the power 4 is equal to c, find x cube plus y cube and x square y square in terms of c. So what we are given is x plus y. So we can write x square plus y square is equal to 1 minus 2xy, and then x square plus y square whole square is equal to 1 minus 2xy whole square. So what this becomes is, it becomes x to the power 4 plus y to the power 4. This will become 1 plus 4x square y square minus 4xy. And then 2x square y square will go from this side and get subtracted. So it will become 2x square y square minus 4xy plus 1. This implies that now this is given as c. So this implies that 2x square y square minus 4xy plus 1 minus c is equal to 0. Now this is a quadratic equation in xy. This equation is a quadratic equation. So xy is 4 plus minus square root of 16 plus 8c minus 8 by 4. That is equal to 1 plus minus square root of 1 plus c by 2. So now we can substitute this value of xy in here to get x square plus y square as 1 minus 2 into 1 plus minus square root of 1 plus c by 2, which is equal to minus 1 plus minus square root of 2 into 1 plus c. And similarly, we have x cube plus y cube is equal to x plus y cube minus 3xy x plus y. And by substituting the value of x plus y, which is 1, and the value of x y, which we have calculated here, we get the value as 2 plus minus 3 by 2 square root of 2 plus 2c. Question 47 says that find all x and y that satisfy x cube plus y cube is equal to 7 and x square plus y square plus x plus y plus xy is equal to 4. So for this, what we do is we let x plus y is equal to alpha and x square plus, and xy is equal to beta. In that case, x square plus y square becomes alpha square minus 2 beta. And similarly, x cube plus y cube becomes x plus y into x square plus y square. This should be minus xy, which is equal to alpha into alpha square minus 3 beta. Okay, because this will become x square x plus y whole square minus 2xy, that is, and this minus xy will become minus 3xy, so minus 3 beta, which is given as 7. And now alpha cube minus 3 alpha beta is equal to 7. Now x square plus y square plus x plus y plus xy is equal to 4, which is a given. So we can rewrite this as alpha square minus 2 beta plus alpha plus beta is equal to 4. So beta is equal to alpha square plus alpha minus 4. Now we have the value of beta, we substitute in this equation, we get alpha cube minus 3 alpha into alpha square plus alpha minus 4 is equal to 7. So we get f of alpha is equal to 2 alpha cube plus 3 alpha square minus 12 alpha plus 7 is equal to 0. Now we see that if we take the sum of coefficients 2 plus 3 plus 7, that is equal to 2. That is equal to 12. So sum of coefficients is 0, and therefore alpha is equal to 1 must be a solution. So we have f1 is equal to 0. Now f of alpha, if you see carefully, if you divide from alpha minus 1, then you will see you can actually divide it twice. So it should be alpha minus 1 whole square, and then the quotient which will remain is 2 alpha plus 7. So the second root would be minus 7 by 2. And once we have alpha, we can find the beta. So when alpha is 1, beta is minus 2. When alpha is minus 7 by 2, beta is 19. When alpha is 1, beta is minus 2, the value of xy would be minus 2, 1 or 1 minus 2. And when alpha is minus 7 by 2 and beta is 19 by 4, then xy are roots of 4t to the power 4 plus 14t plus 19, whose discriminant is less than 0 and hence no real roots are possible. Thus the value of xy is what we have obtained as minus 2, 1 or 1 minus 2. Question 48 says that if alpha, beta, gamma are the roots of the equation x cube plus px plus q is equal to 0, then prove that alpha to the power 5 plus beta to the power 5 plus gamma to the power 5 by 5 is equal to alpha cube plus beta cube plus gamma cube by 3 into alpha square plus beta square plus gamma square by 2. So from Vieta's relationship, we obtain that alpha plus beta plus gamma sum of roots is 0 because the coefficient containing x square is 0. Now product sum of two taken sum of roots taken two at a time as product is p, and product of all three roots is q. So uh, there is a mistake here. This should be minus q. This should be minus q. Okay. So since alpha, beta, gamma are roots of this equation, we substitute alpha, beta and gamma to obtain the equation. Now from this equation, we have sigma of alpha cube plus p sigma of alpha is plus 3q is equal to 0. So sigma of alpha cube is minus 3q. And similarly, sigma alpha square is equal to sigma alpha whole square minus 2 sigma alpha beta, which is equal to minus 2p. So multiplying the given equation by x square, we get x to the power 5 plus px cube plus qx square. And putting x is equal to alpha, beta, gamma, we have sigma alpha to the power 5 plus p sigma alpha cube plus q sigma alpha square. That means sigma alpha to the power 5 is equal to 5 pq is equal to 1 by 5 sigma alpha cube is equal to pq. And therefore that is equal to 1 by 3 sigma alpha square plus half sigma. So this is how we solve it. To understand this sigma notation, I would suggest you to go through cyclic functions chapter in your textbook and you will understand this sigma notation. So yeah, question 49 is same as similar to 48. If alpha, beta, gamma are roots of the equation x cube plus px plus q is equal to 0, then prove that alpha to the power 7 plus beta to the power 7 plus gamma to the power 7 by 7 is equal to alpha to the power 5 plus beta to the power 5 plus gamma to the power 5 by 5 into alpha square plus beta square plus gamma square by 2. So it is, you can solve it in a similar manner. We multiply the given equation by x, and since alpha, beta, gamma satisfy, we have alpha to the power sigma alpha 4, this is cyclic sigma, plus p sigma alpha square plus q sigma alpha is equal to 0. So we have sigma. Now you know that the coefficient of a square in the initial equation is 0, so this will become 0, and therefore uh, sorry, I made a mistake. This is, so in this equation uh, the sigma alpha 4 p sigma alpha square qx, so alpha plus beta plus gamma, oh okay, in this equation alpha plus beta plus gamma is 0 because coefficient of x square is not there, so the sigma alpha would be 0. This term will become 0, and therefore sigma alpha to the power 4 is equal to minus p sigma alpha square, and we multiply the given equation by x to the power 4, we obtain x to the power 7 plus px5 qx4, and so we have sigma alpha to the power 7 plus p sigma alpha 5 plus q sigma alpha 4, and now what we have is sigma alpha to the power 7 is equal to minus p sigma alpha to the power 5 minus q sigma alpha to the power 4. Now we know that sigma alpha to the power 4 is equal to minus p sigma alpha square. There is a missing sigma here, so it becomes minus 5p square cube plus pq sigma alpha square, and thus we have our result here. Question 50 says that if alpha plus beta plus gamma is equal to 0, then show that alpha square plus beta square plus gamma square into alpha to the power 5 plus beta to the power 5 plus gamma to the power 5 is equal to 5 into alpha cube plus beta cube plus gamma cube into alpha to the power 4 plus beta to the power 4 plus gamma to the power 4. So we have alpha plus beta plus gamma is equal to 0. So alpha, beta, gamma are the roots of the equation x cube plus px plus q is equal to 0. So clearly sigma alpha beta is equal to p and sigma alpha is equal to minus q. Now alpha square plus beta square plus gamma square can be written as alpha plus beta plus gamma whole square minus 2 alpha beta plus beta gamma plus gamma alpha, that is 0 square minus 2p, that is minus 2p. And similarly, we can find from by substituting in this alpha beta gamma and then adding those, we find sigma alpha cube is equal to 3 alpha beta gamma, which is equal to 3q. Now multiplying this with x, we get x to the power 4, and thus we find sigma alpha to the power 4 as 2p square. And then we multiply the given equation by x square to obtain this equation, and then we substitute alpha beta gamma and add those to obtain sigma alpha to the power 5, that is 5p cube. And now we have the value for the sum of square of roots, sum of fifth power of the roots, and we put the values, and then we have the powers of 3 and powers of 4, and that's how we have proved it. So this was question number 50. We solved question 51. Show that there does not exist any distinct natural numbers a, b, c, and d such that a cube plus b cube is equal to c cube plus d cube and a plus d is equal to c plus d. So we are given that a cube plus b cube is equal to c cube plus d cube and a plus b is equal to c plus d. So since a plus b is equal to c plus d, we can write a plus b whole to the power 3 is equal to c plus d whole to the power 3. That is 3ab into a plus b is equal to 3cd into c plus d, that is ab is equal to cd. Now a, b are roots. We assume that, not assume, from here we took a plus b as m and ab as n. So a and b would be the roots of the quadratic equation x square minus mx plus n is equal to 0. So this means a, b are the roots of this equation as well as c and d are also the roots of this equation. That quadratic equation can have at most two distinct roots, but we are having four roots. So the given condition is simply not possible. Question 52 says that determine all the roots of the system of simultaneous equation x plus y plus z is equal to 3, x square plus y square plus z square is equal to 3, and x cube plus y cube plus z cube is equal to 3. So this is a very straightforward problem. Let x, y, z be the roots of the cubic equation t cube minus 80 square plus bt minus c is equal to 0. So x plus y plus z is equal to a, x plus xy plus yz plus zx is equal to b, and 2xy plus 2yz plus 2zx will become 2b, which will be equal to x plus y plus z whole square minus x square plus y square plus z square, which is equal to 6. So we have 2xy plus 2yz plus 2zx. Now we substitute x, y, z in given equation and we add those. We get x cube plus y cube plus z cube minus a x square plus y square plus z square plus b x plus y plus z minus 3c is equal to 0. Now we are given that b is equal to 3 here. Okay. So we substitute b is equal to 3 and x plus y plus z is also 3. So this is 9. And we had our a is also 3, x plus y plus z is 3. So this is 3 and 3, 9. So this is 9 and 9 will cancel each other. And this is given as 3 as well. So 3 minus 3c is equal to 0, which means c is 1. So our equation is t cube minus 3t square plus 3t minus 1 is equal to 0. That is t minus 1 whole cube, and thus roots are 1, 1, 1. Okay, now we solve question 53. Given real numbers x, y, z such that x plus y plus z is equal to 3, x square plus y square plus z square is equal to 5, x cube plus y cube plus z cube is equal to 7, find x to the power 4 plus y to the power 4 plus z to the power 4. So this is a similar problem like we have solved earlier. We find x plus y, xy plus yz plus zx is equal to half x plus y plus z whole square minus x square plus y square plus z square. Now x plus y plus z is 3 and x square plus y square plus z square. Oh, sorry, this one. This is 3 and this is 5. So 3 square minus 5. 9 minus 5, 4 divided by 2 is 2. Similarly, x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So this is 3 and this is 5. and 5 minus 2 is 3, 3, 3 is 9. So, and this is 7. So 9 minus 7 is 2, and then we divide by this 3, we get minus 2 by 3. Now x to the power 4 plus y to the power 4 plus z to the power 4 is equal to x square plus y square plus z square minus 2 of xy whole square plus yz plus zx whole square. Now this was given as 5, so it becomes 25, and this is nothing but 2 into xy plus yz plus zx whole square minus 2 of xy square z plus zxy square plus xyz square, which is xyz into x plus y plus z, and we solve it, we get the value as 9. Question 54 says that if alpha beta are roots of the equation x square minus a plus d plus ad minus bc is equal to 0, show that alpha cube plus beta cube are the roots of the equation x square minus a cube plus d cube plus 3abc plus 3bcd into y plus ad minus bc whole cube is equal to 0. Excuse me. So we are given that alpha plus beta is a plus d and alpha beta is ad minus bc. So we compute alpha cube plus beta cube. So that would be alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. That is a plus d whole cube minus 3 into ad minus bc into a plus d. And we solve this, we get this as the value for alpha cube plus beta cube. So yeah, and alpha cube beta cube is simply ad minus bc whole cube. And now we have sum of roots, that is the equation whose roots are alpha cube and beta cube. The sum of roots is here and product of roots is here. So the equation is pretty straightforward to obtain. Question 55 says that if a cube plus b cube plus c cube is equal to a plus b plus c whole cube, prove that a to the power 5 plus b to the power 5 plus c to the power 5 is equal to a plus b plus c whole to the power 5. Generalize your result. So we are given that a cube plus b cube plus c cube is equal to a cube plus b cube plus c cube plus 3 into a plus b into b plus c into c plus a. So a plus b into b plus c into c plus a is equal to 0. So which implies that a plus b or b plus c or c plus a is equal to 0. One of these would be 0. So in any case, a to the power 2n plus 1 plus b to the power 2n plus 1 plus c to the power 2n plus 1 is equal to a plus b plus c to the power 2n plus 1. Because if a plus b plus or b plus c or c plus a is equal to 0, then this will reduce to one of this, okay, c to the power n. And for example, let's say a plus b is 0, so is equal to 0. So this will become 0, this will become c to the power 2n plus 1, and that will get cancelled. And then we will have a to the power 2n plus 1 plus b to the power 2n plus 1, which we can resolve as a plus b into a polynomial of second of the degree 2n, and a plus b being 0, this will make this 0. So from this, for n is equal to 2, a to the power 5 plus b to the power 5 plus c to the power 5 is equal to a plus b plus c to the power 5. Question 56 says that if p, q and r are distinct roots of x cube minus x square plus x plus minus 2, find the value of p cube plus q cube plus r cube. So we are given that equation x cube minus x square plus x minus 2. We substitute pqr into that and we add those, and we obtain p cube plus q cube plus r cube is equal to p plus q plus r into p plus q plus r whole square. We are not substituting into that. I don't think we are substituting. We are just writing it down. P plus q plus r into p plus q plus r whole square minus 3pq plus qr plus rp plus 3pqr. And from Vieta's relationship for this equation, we have p plus q plus r is equal to 1, pq plus qr plus rp is equal to 1, and pqr is equal to 2. So we simply substitute in this equation. We obtain p cube plus q cube plus r cube is equal to 6. Okay. Question 57 says that find the sum of the fifth powers of the roots of the equation x cube plus 3x plus 9 is equal to 0. So we let ABC be the roots of the equation. So from Vieta relationship, we have a plus b plus c is equal to 0, because in this equation, coefficient of x square is 0. AB plus BC plus CA is equal to 3, and ABC is equal to minus 9. So now we substitute ABC in this and we add, we get a cube plus b cube plus c cube plus 3 into a plus b plus c plus 27 is equal to 0. So we substitute the value of a plus b plus c, that is 0. We get a cube plus b cube plus c cube is equal to minus 27. Once we have this, what we do is multiply the given equation by x square and we put x is equal to abc and add. We have a to the power 5 plus b to the power 5 plus this should be c to the power 5, not 3. And then we have 3a cube plus b cube plus c cube into plus 9a square b square plus c square. And then we simply resolve and simplify, we get 135 as answer. Question 58 says that find the sum of fifth powers of the roots of equation x cube minus 7x square plus 4x minus 3 is equal to 0. So in this case, again from Vieta's relationship, we have a plus b plus c is equal to 7, that is this guy, ab plus bc plus ca is equal to 4, this guy, and abc is equal to 3. So again, we compute a square plus b square plus c square in similar manner, and we get 41 as the value. We have now, once we have our a square plus b square plus c square, a plus b plus c, and abc, bc, ca, and abc, what we do is we substitute x is equal to abc, and we add that. So we get a cube plus b cube plus c cube is equal to 7 a square plus b square plus c square minus 4a plus b plus c plus 9. And then we substitute the values of a square plus b square plus c square, that is 41, 7 into 41. And then we substitute a plus b plus c, that is 7, 4 into 7, and 9, we get 268 as the answer. Once we have this, we do the same for x to the power 4. By multiplying x, we obtain for a to the power 4 plus b to the power 4 and c to the power 4. And once we have that, what we do is we multiply by x square and we do the same thing for power 5, and we have this given result. So it was one step more than the previous problem. Question 59 says that alpha, beta, gamma are the roots of the equation x cube minus 9x plus 9 is equal to 0. Find the value of alpha to the power minus 3 plus beta to the power minus 3 plus gamma to the power minus 3 and alpha to the power minus 5 plus beta to the power minus 5 plus gamma to the power minus 5. So we are given that alpha, beta, gamma are the roots of the equation. So alpha plus beta plus gamma is equal to 0 because the coefficient of x square is 0. Alpha, beta plus beta, gamma plus gamma alpha is minus 9. And alpha, beta, gamma is also minus 9. Now in the given equation, we substitute 1 by alpha, 1 by beta, 1 by gamma, and we add. So it will become 1 by alpha cube, and when substituted with alpha, then 1 by beta cube and 1 by gamma cube. So the right hand side will become 9 into 1 by alpha plus 1 by beta plus 1 by gamma minus 27. So this will become 9 into alpha beta plus beta gamma plus gamma alpha by alpha beta gamma minus 27. Now alpha beta plus beta gamma plus gamma alpha and alpha beta gamma both have value of minus 9. So this will become minus 18. Now we multiply the given equation by x square and then we substitute x is equal to 1 by alpha, 1 by beta, 1 by gamma. And then we have the minus 5 power for each of these, and then we have the minus 3 power and minus alpha to the power minus 2, beta to the power minus 2, gamma to the power minus 2. It's a simple matter of substituting the value and resolving this guy, the second term, and you get 4 by 9 as answer. Question 60 says that find the cubic equation whose roots are alpha, beta, and gamma such that alpha plus beta plus gamma is equal to 9, alpha square plus beta square plus gamma square is equal to 29, and alpha cube plus beta cube plus gamma cube is equal to 99. Also find the value of alpha to the power 4 plus beta to the power 4 plus gamma to the power 4. So we are given, we let the equation, cubic equation to be x cube plus a x square plus bx plus c. So from Vieta's relationship, we have a is equal to minus alpha plus beta plus gamma, which is given as 9. Okay, so a would be minus 9. Similarly, alpha beta plus beta gamma plus gamma delta would be alpha plus beta plus gamma whole square minus alpha square plus beta square plus gamma square by 2. Now alpha plus beta plus gamma is given as 9 and alpha square plus beta square plus gamma square is given as 29. So 9 square minus 29, 81 minus 29, that is 62 minus 2, 52 minus 2, that would be 26. And similarly, so b becomes here 26. So we have found the value of a and b. Now we put x is equal to alpha, beta, gamma in the equation, and we substitute the values. We get c is equal to minus 24. So our equation is x cube minus 9x square plus 26x minus 24 is equal to 0. And then like previous problems, we multiply this with x and we substitute alpha, beta, gamma, and we get alpha to the power 4 plus beta to the power 4 plus gamma to the power 4. And then we simply substitute the values of the known terms and we get 353 as the answer. So there are some typing mistakes in the book. I apologize for that. It's quite easy to lose track among the LaTeX equation. I will try to correct these to the best of my ability. So I hope that you are finding these problems interesting and satisfying in nature. And I hope that you are becoming better at mathematics by watching these videos. And in case of any problem or suggestion you have, you can make use of the comment box and tell me what do you think, and I'll try my best to help you. So thanks a lot for watching the video. Have a nice day.